Thanks for clicked this video. Now I will talk about deep learning. If anyone interested this topic, please view full poly list of this topics. Deep learning, also known as deep structured learning, is part of a broader family of machine learning methods based on artificial neural networks with representation learning. Learning can be supervised, semi-supervised or unsupervised. Deep learning is a class of machine learning algorithms that multiple layers to progressively extract higher-level features from the raw input. For example, in image processing, lower layers may identify edges, while higher layers may identify the concepts relevant to a human, such as digits or letters or faces. Deep learning architectures such as deep neural networks, deep belief networks, deep reinforcement learning, recurrent neural networks and convolutional neural networks have been applied to fields including computer vision, speech recognition, natural language processing, machine translation, bioinformatics, drug design, medical image analysis, material inspection and board game programs, where they have produced results comparable to and in some cases surpassing human expert performance. The adjective deep in deep learning refers to the use of multiple layers in the network. Early work showed that a linear perceptron cannot be a universal classifier, but that a network with a non-polynomial activation function with one hidden layer of unbounded width can. Deep learning is a modern variation which is concerned with an unbounded number of layers of bounded size, which permits practical application and optimized implementation, while retaining theoretical universality under mild conditions. In deep learning, the layers are also permitted to be heterogeneous and to deviate widely from biologically informed connectionist models for the sake of efficiency, trainability, and understandability, whence the structured part. Most modern deep learning models are based on artificial neural networks, specifically convolutional neural networks, CNNs, although they can also include propositional formulas or latent variables organized layer-wise in deep generative models such as the nodes in deep belief networks and deep Boltzmann machines. Most deep learning systems rely on training and verification data that is generated and/or annotated by humans. It has been argued in media philosophy that not only low-paid click work is regularly deployed for this purpose, but also implicit forms of human microwork that are often not recognized as such. The philosopher Rainer Melhoff distinguishes 5 types of machinic capture of human microwork to generate training data. Number 1. Gamification. The embedding of annotation or computation tasks in the flow of a game. Number 2. Trapping and tracking, CAPTCHAs for image recognition or click tracking on Google search results pages. Number 3. Exploitation of social motivations. Tagging faces on Facebook to obtain labeled facial images. Number 4. Information mining. By leveraging quantified self devices such as activity trackers. Melhoff argues that in most commercial end-user applications of deep learning such as Facebook's face recognition system, the need for training data does not stop once an AN is trained. Rather, there is a continued demand for human-generated verification data to constantly calibrate and update the AN. For this purpose, Facebook introduced a feature that once a user is automatically recognized in an image, they receive a notification. They can choose whether or not they like to be publicly labeled on the image or tell Facebook that it is not them in the picture. This user interface is a mechanism to generate a constant stream of verification data to further train the network in real time. As Melhoff argues, involvement of human users to generate training and verification data is so typical for most commercial end-user applications of deep learning that such systems may be referred to as human-aided artificial intelligence.